So I'm going through the class notes for MYP2 Unit 2, and here's Chapter 4, which is standard form. So we've already talked about powers of 10 and standard form, also known as scientific form. It's got a Danish name, Den videnskabelige skrivemåde, the scientific method of writing, literally. So what is the distance from the Sun to the Earth? So as it happens, it's 1496 and a whole bunch of zeros, 7 zeros in meters. And for scientists, it's very inconvenient to have to write all of the zeros when you have very big numbers like that represent the distances in space. So in science, we encounter lots of very large numbers, e.g. representing distances in space, and lots of very small numbers, e.g. representing the dimensions of subatomic particles I've written. And scientists have a special way of writing such numbers so that you don't need all the zeros. And here's how I set it out. So I started off with the number 14960000000, and then I thought of a number between 1 and 10 that used the same digits. So 1496, my number was 1.496. That's a number between 1 and 10. And I multiplied that by a number that was a 1 with lots of zeros. And very importantly, I wrote that number that was a 1 with lots of zeros directly underneath the number I started with. And the point of that is to get all the columns in the right place and get the right number of zeros, because just having the numbers lined up like this, you can see with a 1 there and then a 1 in the same column underneath, you can see that the number that's the 1 with loads of zeros, when you multiply it by 1.4, so 1 and a bit, gives you a number that's slightly bigger, a number that's a 1 there but with a 4 in the next place. So hopefully writing it in columns like that, writing it lined up, helps you to see that this number multiplied by 1 and a bit, 1.4 something, gives you this number with a 1 in the same place but a 4 there. And that can be written in a shorter way, 1.496 times 10 to the power of 10. This number here, a 1 with 10 zeros, is 10 times 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 10, which is 10 to the power of 10. And that's a much easier way to write that number, 1.496 times 10 to the power of 10. It's a much shorter way to write the number. So 1.496 times 10 to the power of 10 is an example of a number written in standard form. And the format of standard form is that the first number is something between 1 and 10, and then it's multiplied by a number that is a power of 10. So standard form is something between 1 and 10 times something to the power of 10. So here's an example. Express this number here, 312 million in standard form. So I've written the number first, 312 million. Over here I've written a number between 1 and 10 that uses the same digits, so 3.12, and then multiplied by, and then lined up with my original number, I've put a number that's a 1 with lots of zeros. And writing it lined up like that, you can see that the number with lots of zeros multiplied by a number that's 3 and a bit gives you a number that's got a 3 in the first column instead of a 1. You can see just by lining the number up that this number multiplied by about 3 gives you this number. And 3.12 times this number, that's a 1 with 8 zeros, is the same as 3.12 times 10 to the power of 8. When you see a number that's a 1 with lots of zeros, you've just got to count the zeros, and that's what it's 10 to the power of. So that's an easy pattern there. And people make the mistake of counting the zeros in the original number. So if you look at the original number, it's got only 6 zeros in it, but when you write the number here, it's got 8 zeros in it, because the 0.12 is swallowing up 2 of the places that have zeros in it here. So that's why it's super important to get things lined up and get the right number of zeros, because it's very easy to make the mistake of looking at the number of zeros in the original number and getting that wrong. So the final answer, 3.12 times 10 to the power of 8, that's in standard form because it's something between 1 and 10 multiplied by 10 to the power of something. So remember the powers of 10. 10 to the power of 4 is 10,000. 10 to the power of 3 is 1,000, and so on. And then you go a bit further down. 10 to the power of 1 is a 10 on its own. 10 to the power of 0 is 1. Remember, there's a pattern here that we're dividing by 10 every time to get from one line to the next. So when we go from 10 to the power of 4 to 10 to the power of only 3, it's less by a factor of 10. And this still applies when we get down to 10 to the 1 is 10. So the next one in that pattern should be 10 to the power of 0 is 1, because 10 divided by 10 is 1. So that gives us one of our rules that we already discussed, that anything to the power of 0 is always 1. But then we carry that pattern on a little bit further. 10 to the power of minus 1 has to be 0.1, because you divide the previous line by 10. 10 to the power of minus 2 is 0.01, because you're dividing the previous line by 10. And 10 to the power of minus 3 is 0.001 from dividing the previous line by 10. So that's another thing we need to remember to be careful about. When you see a minus power, it doesn't mean that it's a minus number. It just means that it's a small number. And finally, just a little pattern to notice that's going to help you here. Power of 4 gives you a number that's a 1 with 4 zeros. Power of 3 gives you a number that's a 1 with 3 zeros. And even looking at the negative powers, power of minus 3 gives you a number that's 3 zeros, but on the other side of the 1, as long as you remember to include the 1 before the decimal. So just zooming in a bit to highlight that point. Power of 4, 4 zeros in the number. Power of minus 3, 3 zeros in the number. There it is, just there we go. So that's going to help you when you're writing numbers in standard form to quickly spot what the power is. It's always the same as the number of zeros in the number, and that applies to negative powers for small numbers as well as positive powers for big numbers. So here were some questions. Write these 3 numbers in standard form. The first 2 are straightforward, that you just set those out the same way as the examples. The third one you need to think about a bit more, because it's a small number, so you need to think about how to line things up right to get the decimal in the right place. Pause the video, have a go at those before moving on. So here's the first answer. So start with the number 308 and a whole bunch of zeros. The number between 1 and 10 that uses the same digits is 3.08. And then underneath the original number, I've written a number that is a 1 with lots of zeros. And lining it up like that, I can see that this number here, multiplied by about 3, will give you this number here, because it's got a 1 here, but a 3 there. So 3.8 times, or 3.08 times 1,000,000,000,000, that's 9 zeros there, so that's 3.08 times 10 to the power of 9. The second one, a little bit messy there, but 64,000 is 6.4 times 10,000. And again, lining the numbers up, you can see that 10,000 times about 6 gives you this number here, because you've got a 1 in the first place here, but a 6 there. And that's 6.4 times 10 to the power of 4, because 10,000 is a 1 with 4 zeros. And then finally, question 3, which is the tricky one. 0.00054. So our number between 1 and 10 is 5.4. Then I need to be careful when I write a number underneath it, because the classic mistake would be to write a number of the same length and go 0.00001, and then you'd end up with a number that was 54 times as big. So the number we need to write is 0.0001, and then just looking at the way the numbers line up in the columns, you can see that the number we started with is about 5 times as big as 0.0001, because 0.0001 has got a 1 there, and 0.00054 has got a 5 in the same column. You can see it's about 5 times as big from having the numbers in the right columns. So the number we started with is equal to 5.4 times 0.0001, and that's the same as 5.4 times 10 to the power of minus 4. So more questions. This time it's the other way around. Write these numbers as ordinary numbers. So you've kind of got to do the same thing but backwards. So pause the video, have a go at that. So I hope you paused the video, and let's go through them. So 5.6 times 10 to the power of 4 is 5.6 times 10,000, because that's a 1 with 4 zeros. And 5.6 times 10,000 is 56,000. And again, you can see I've lined up the columns. I can see that 10,000 times about 5 should give me a number that has a 5 in the first column instead of a 1 in the first column. So it's very easy to get that wrong and end up with the wrong number of zeros, because 10,000 has 4 zeros and 56,000 only has 3 zeros. But lining things up nicely in columns helps you to see you've got it right. 10,000 times about 5 should give you a 5 in the first column instead of a 1 in the first column, because it's about 5 times as big. Second question, 3.012 times 10 to the power of 6. So I've written that out long ways as 3.012 times a 1 with 6 zeros, in other words a million. And then underneath that I've multiplied it out. So I can see that a million times about 3 should give us this number here, that's about 3 million. And writing things nicely in the columns, you can see that a number with a 1 in the first column multiplied by about 3 should give you a number that's got a 3 in the first column. So even though 3,012,000 only has 3 zeros at the end, as well as a 0 there, you can kind of see that that's right, can't you? And then question 3 is a little bit harder because it's a small number with a negative power. So 3.41 times 10 to the power of minus 6 is equal to 3.41 times 0.000001. So that number has got 6 zeros in it, including the one before the decimal point. 10 to the power of minus 6, 6 zeros. And then again, writing things nicely in line helps you to get the right magnitude of number. So 0.000001 multiplied by about 3 should give you a number that's got a 3 in this column. I nearly said the last column, but it's not the last column of the final number. Should give you a number that's got a 3 here in this column instead of a 1. So you can see just by the place value and where the columns are that this number multiplied by about 3 gives you this number. Okay, so it's very important to get the numbers and the place value right and the numbers in the right columns, because it's very easy to make the mistake of ending up with a number that's 341 times as big instead of only being 3 times as big. So the final answer is 0.0000341. Okay, well, the next thing we did in class was exercise 2C.1 on pages 34 to 35 of the MYP4 book. And I went through some answers in class. I won't go through them on this video, but you can pause the video if you like.